Hello, good afternoon, everyone. This is Dr. Venkatesh, Nanopore from Genotypic Technology, and we are here to discuss the Nanopore technology and its applications. This is the third in our series of webinars on Nanopore technology, and we look forward to working with you on this technology and try to place to work with you on the nanopores. So briefly to touch upon how Genotypic has evolved and how it has, turned out to be pioneers in the field of genomics. I will just take you through a brief presentation on how, Genotypic was incorporated in 1998, how it started in its operation in 2000. Then we introduced the first spotted microarray in India in 2001. Followed by the first NGS sequencer in 2011. And in 2017, we actually introduced do-it-yourself products in genomics. And this we did in collaboration with the Oxford Nanopore Technology, which is one of the pioneers in the pore-based sequencing technology. And it is represented in more than 70 countries, and the technology is being used in various fields of research. We ourselves have been able to install more than 100 nanopore installations across India, and our DSIR certified R&D has done more than 200 projects using nanopore sequencing for a variety of applications. So with this brief introduction, welcome to the world of long read sequencing with Minion, which is one of the very small instruments from Nanopore technology. And this is a technology which is rapid, which is affordable to everyone, it's real time, and it is portable. And when I say affordable, actually it has created a revolution because it has democratized the sequencing technology, and now individual labs can actually own sequencing platforms for their lab. So it is no more limited to central facilities. Coming to the nanopore DNA sequencing sensing chemistry, basically it consists of 4 key players. One of them, the very crucial one, is the pore, which is a bacterial origin protein, channel protein, and this is actually involved in sensing of the analyte, that is DNA or RNA. And then we have, it is embedded in a synthetic polymer membrane, as well as then we have one more protein which is called as motor protein, or simply it is a helicase, which is to unwind the DNA. And then we have the suitable command lines for and algorithms to decipher the data that is generated during the sequencing protocol. So with basically what happens is when the double-stranded DNA along with the adapter sequence is actually used to make the library, then the DNA passes through the pore, and as the DNA passes through the pore, it interacts or interferes with the free flow of current or the electricity, resulting in certain specific signals. And these electrical signals, called squiggles, are actually used to generate the base pair data. So what are the advantages of working with nanopore technology? The working with nanopore technology is, has many fold of advantages. One thing is, I told it's a long read technology. In fact, it is not long read, it is ultra long read. What I mean by ultra long read is you can generate up to 2 MB data. Okay, and whereas the conventional technologies can generate, like say, between 300 to 600 base pair, this technology actually gives you 2 MB long reads have been reported already. In our own lab, we have generated like 1.2 MB long read. So this helps in it helps in many ways, because this actually helps in gap filling for the data which has been generated on other technologies, or to span the structural variations or repeat regions. So this is so having a long read is a lot more useful than having a short read, and thereby nanotechnology is not only basic research, it has also become a real-time sequencing. So the other important aspect about this is it's a real-time sequencing. So what do I mean by real-time sequencing is, as you start the sequencing, you can actually see what is your data, and you can actually take an informed decision to either continue the sequence run, or to actually stop the run, and or to stop the run. And this is the only technology where actually you can save the, you can stop the run and save the flow cell at 4 degrees and reuse it either with the same sample or new sample uh, after some time when you are ready for the second run. As I told you, it's a very small and portable. The device called Minayan is a very small and portable device, and it is a very low cost. One more important aspect about this, or the feature about this technology, is it doesn't need, the normal workflows don't need any amplification. So as a result, you don't get into the PCR biases or PCR introduced errors, and the standard it's a very simple sample preparation steps. So within 10 minutes, actually, it is possible to prepare a library. This is a chemistry called as rapid chemistry. Then we have 1D, which is like single strand sequencing in case of Illumina, which takes about 60 minutes, and then 1D square chemistry, which is like sequencing both the strands, and it takes about 80 minutes. So you can see, like, literally within about 2 to 3 hours time, you are ready to go in for your sequencing project, and thereby saving you a lot of time. Coming to the variety of devices that are available, you have we have right from a 90-gram Minayan to Prometheon, which can generate up to 7 TB data. So basically, there are three classes depending on your use and your requirement of sequencing. You can actually use any of the devices. So Minion is generally used, you can be used when you have small sequencing requirements, and in your lab you want to work with it. So, and there you can use Minion, whereas Gradion, when you have actually more samples to work with, and like for example, few thousand metagenome samples or a plant genome kind of a thing, you can use Gradion. And Prometheon is for really huge sequencing projects. For example, in case of population sequencing of Indian population, or large scale genomic you know sequencing. So basically, based on your requirement, one can select the device. Uh, so coming to the Minan, which is the smallest of all and can be afforded by anyone. So basically, here in this slide, you are looking at the Minan, where this is the hardware, and you have a flow cell. So flow cell is the place where actually the nanopore chemistry works and the sequencing happens. So you can the sample is added over here, loaded over here, and when this minion is connected to a PC or a laptop, and with that power itself, actually the sequencer works, and the data is generated and transferred to the the computer, and can be either analyzed in real time, or it can be analyzed at a later point. So it's a very simple thing, wherein you don't need too much of infrastructure. In fact, you don't need anything like a clean room or anything like that. Now, coming to the workflow, as I told you, it is a very simple workflow. You can actually decide based on your application between 10 minutes to 80 minutes is what it requires to prepare the library. So this just introduces you to briefly about the workflow. It begins with DNA RNA extraction, followed by a library preparation step, and followed by loading onto the sequencer. So the sequencer is actually controlled by a user interface called as MinNow, and the data that is generated, I told you about the electrical signals, which is called a squiggle. So they are in FAST5 format, and they are it needs to be further converted into FASTQ format using either AlbaCore or GupP. Or when it is live, you can actually get the FASTQ directly. So this is just to show you how it looks in real time. For example, these are the various screens that you see when the machine is in sequencing mode. So the first one is representation of pore occupancy. So you can make out how many pores are occupied, how many pores are vacant, how many pores are dead, and also like this shows the pore occupancy over here. You can even monitor the read lengths and how many reads have been generated in real time. Even pore activity, like with the trace viewer, you can even look at the activity of individual pores. The other good thing is, like, as it actually comes with many tools. For example, these are called as Epi2Me tools. So this comes with something called as What's in My Pod. So basically, for example, if you are doing a metagenome project, you can directly upload the data onto this, and it will analyze the data and give you like phylogenetic tree, donut chart, everything very almost in a report kind of a format. And then you can, like that, there are programs for antimicrobial resistance, 16S metagenome, and exome sequencing, etc. So all these things comes with your access to the nanopore community, which you get by going for the sequencer. Coming to what are the areas of research where you can use. Literally, you can see that there is a wide, area of fields of research where you can apply nanopore sequencing, right from pathogen or in microbiology to microbiome studies, plant research, transcriptome analysis, population genomics. Everywhere people have used nowadays, increasingly, like clinical research and cancer research also people are using. So basically, it can be used for any applications, like I have told you, whole genome sequencing. You can either sequence a bacteria, you can say sequence virus, fungus, plants, human, everything that any live organism can be with DNA can be sequenced, or RNA can be sequenced. Then metagenome sequence, like from the environmental samples. You can do targeted sequencing, like PCR based sequencing can be done using this. Transcriptome sequencing, you can look for fusion genes in case of cancer and things like that. And apart from that, this is the only technology where you can actually look at the direct DNA or RNA sequencing and look at the modifications, RNA-based modifications. Similarly, epigenetic studies like methylation studies and base modification in case of DNA can be extracted from the data which you have actually generated from whole genome sequencing. So this is the advantage by by using such a small instrument. You can do wide variety of applications. And another important thing is actually it has been used in wide or various different kinds of environments. For example, this is the only sequencer which has been used in the space to the glaciers and on beach, underwater, in real time, like in the areas where there was a Ebola outbreak, and for studies in biodiversity studies in case of forests. So all these things actually has been possible just because of the presence of MinION. And anybody who is actually looking at these kind of work, this is the best suitable sequencer available in the market. Obviously, the next question you would be looking at how much publications have come out. So till date, more than 400 publications are available, and many of them are in high impact, publications like in case of Nature and or in Science. From India, Genotypic has been instrumental in the first 4 publications. Okay. That came out from India in along, like one in human study, and the other 3 in the plant studies. So as you can see, this is a big advantage. There's a big advantage using this technology, and Genotypic has made it much more simpler so that anybody can adapt and easily start using this technology. So how do we enable you to do your research? The one thing is we act as a one-stop solution. For example, we have all the devices. We deal with all the devices, and we have our own analysis team. We give technical support on that. We also deal with all the kits and reagents. Anything to do with Nanopore, we do it. Okay, and even any software updates and all. Then apart from that, we also supply everything that is required along with Nanopore reagents or instruments that are required in preparation of library. So this could be in case of a PCR based or amplicon based sequencing, it could be a PCR machine, or for DNA RNA QC, which is very important in case of Nanopore sequencing, a qubit, which is a fluorescence based DNA QC equipment, then Vortex magnetic stand. Apart from that, we have reagents. As you can see, we have actually tied up with many companies, right from Thermo Fisher, Beckman, NEB. So any reagent or the equipment that you actually desire to have along with the Nanopore, you can actually approach us. Then we have developed our own data analysis software called Commander, which actually allows you to to be free from any command line scripts that might be required to run some of the programs, some of the algorithms. And apart from that, we also do workshops and training consultancies and technical support. So any kind of support you need from Genotypic is available in for you. So this is one way how we have actually enabled a lot of scientists. So basically, here I want to show you is we not only actually provide the MinION, we also provide all other peripherals, right from computer, a working computer which has been actually tried and tested at Genotypic with the necessary softwares, and all the reagents, the qubits along with reagents and the softwares. For example, if you are planning to go for a Nanopore sequencing, we also give our own new Commander software. And then we also have this mini genomics lab, which is very useful for many diagnostic labs. Okay, and we ourselves have installed many quite a few systems across India. So here basically this comes with all. So basically, Nanopore sequencing needs only these many small equipments, and we can actually make it as a package, and which makes it much cheaper for you to along with the training, and can be installed. Then we have another setup called as mini molecular biology. This is very useful if you are doing field-based studies or you are into academics and you want to train your students. So this comes with a portable 8 well 16 well PCRs along with reagents and ready to load this one electrophoresis equipment, and ethidium bromide free stain and things like that. So basically the whole system is a very easy to handle along with laptop and everything, so that you can immediately start a demo for your students at your own institution. As I told you, we also have developed a new software which is called as Commander. The Commander is actually basically it commands the command lines, and it can do everything right from base calling to faster conversion of fast queue to faster format. It can be used by Illumina people who are dealing with Illumina data or Nanopore data, PacBio data. Basically, any data is fine to work with Commander, and you can even do local blast using that Commander. And we also have some specialized features like beyond Excel, wherein you can actually extract your publications of your interest, the authors of your interest. So basically, when you are writing a publication, there's nothing like having a Commander next to you. We are actually participating in in the most important event for Oxford Nanopore users, that is called as London Calling, which is on 22nd to 24th May. And we actually invite you cordially to be part of this, and you could approach us if at all you want to attend this conference. Thank you, and we are open to any questions.